Right, I'm just going to leave this in here. If I go back and check my answers, I've just noticed a mistake from looking at my calculation. So I'm going to leave it in just to show you what you should do. Okay, so I said it was yes. So if I go back through my calculations, just read what I did. Look at this calculation here. Just by me rushing, you can see that I haven't got this properly done. So if I go back and actually change that, this is what you should do, is checking everything. You can see that the actual volume, I'll change it, is this. So we can lose that. So this, I'll show you what's wrong with the calculation. That's wrong. That's wrong. That's wrong. Okay, so if I actually do it, so 34457.625, if we divide that by 1,000, we get 344.057, and we're going to divide that by 13.5. So there, 344.057. When I do that, the answer is not 4.8, it's 25.4870. So it needs 25 and a bit more. So the answer isn't yes, it is no. So I'll clearly say that on the next video, that there is a mistake on question 17. I knew I'd get like so far and make a mistake, but there is a mistake on question 17. So the start of this video will be where I just changed that mistake. And the mistake was that when I was typing in my calculator, instead of saying 120, I put 20, and I paid the price because the rest of it had a knock-on effect. If you do that in the real assessment, in the real exam, you won't lose 4 marks, you'll lose 2, perhaps. Okay, it just depends how clear you've been with your processes. Okay? Right, next one. Hopefully I have a little bit of a run again where I do alright, because question 17 is a result for me. Right, question 18. T is inversely proportional. T is inversely proportional to the cube of u. Done. Inverse means you have the fraction to start off with. Okay. When u is 5, so when u is 5, and t is 0.15. Okay. So what we have to do is rewrite the original formula without k as a letter as a value. So let's do that. So we're going to times by that 5 cubed. I think it's k. So k equals whatever it equals. So 18.75. Oh, I need to read the question. Okay. I'm just going to leave this mistake in. You just have to see what it's like. Okay. So read the question. I read that question. I'm absolutely full. So it's actually 0.096 equals k over 5 cubed. Same idea. So we're going to times by 5 cubed. Okay, so k equals 0.0096 times 5 cubed. So 0.0096 times by 5 cubed. Some advice: if you're working on a cold, you have to properly be checking your work, because I'm working on a cold and I'm making mistake after mistake after mistake. And I think when I've not got a cold, I've got the energy to like stop the video, do another video, but today I've just not got the energy, so I'm just going to keep it as it is. So now we've got the value of k. Like I said, we're going to rewrite our formula without that. So 1.2 over u cubed. It's then saying if t equals 0.15, which I was using a minute ago, what's u? So let's do that. T is now that. What we need to do now is rearrange this, so they're going to trade places. Okay, you can times by u cubed and divide by 0.15, but they will swap places. So u cubed equals 1.2 over 0.15. And then to find u by itself, we're going to cube root. So we just do the inverse of that. So cube root of 1.2 over 0.15. Okay. So type it all in one go. So cube root of fraction 1.2 over 0.15. So it's 2. Okay, there we go. So hopefully, I mean, I can tell you it might be a bit more wound up on this, but hopefully you haven't copied that completely down and got it all in the way. Hopefully you can still do the question. But it is about reading the question and stop being careless like me. I'm trying to do this before it's dinner, so I'm trying to get it out of the way, but you won't. You'll just have all the dedicated time in the exam, so pay attention to what you're doing, read the question. Right, question 19. Complete the square, find the coordinates of the turning point with a curve, the equation y equals x squared plus 10x plus 18. The turning point of a curve is the same idea as the question where it gave you a graph earlier on, but you've not got the graph, you've just got the equation. Okay, so what we have to do is complete the square. Okay, and it says complete the square. It's not even like in our starters it hasn't even got this in here. I'm just saying what is the turning point, what's the minimum point, and so on. But it's telling you to do that. So complete the square. Let's get some of the basics in. You've got the bracket with the square on it. We have x, and we have the value of the coefficient of x, which is 10. So we have that to make it 5. We stick it in there. We then square that, then subtract it, and the number on the end, 18, gets put on the end. So x squared plus 5 all squared, take away 25, add 18. So, oh, get rid of that. So x plus 5 all squared minus 7. Use your calculator for that bit. That is in the right format to be able to use to get the coordinates. The value on the end is just the value in there. And remember, this one we do the opposite, so that's going to be minus 5. Okay, so if this was a standard y equals x graph, like that-ish, that should be 0, 0, this would have gone left 5, down 7, so it would have moved like that. So this is how we would understand how the graph is being transformed or translated. Okay, this is your horizontal movement, this is your up and down movement. Okay, right, question 20. Circle theorems. Okay, so I've been trying. I gave you the printout the other day where you have the circle theorems, so you could get the phrases to be consistent with them. But as long as you've got enough information when you're saying it, you'll be fine. Okay, so A, B, C, D are points in the circle, so it's telling you they're definitely hitting the edge of the circle. EDF is the tangent, so we're bringing in ideas about tangents meeting points. So it could be about the radius, or it could be about the alternate segment theorem where we've got a tangent. ADE is the angle there, look. ADE is 54, so that is 54. And angle ABC is 114. Work out the size of CAD. Work that out. You must give a reason for each stage of your working out. Okay, so there's a few things I could do. You've just got to think carefully what's going on. I have a four-sided shape inside a circle. That is a cyclic quadrilateral, so I can figure out this angle here now. Okay, ADC. Okay, so that's what I'm going to do. So ADC equals 180, take away 114, because opposite angles in a cyclic quadrilateral equal 108 degrees. So that will be, what will that be? 66. Okay, so that's that one. Now I've got that, I've got a couple of options. I could perhaps find this angle here, or find this angle here, because now the only thing I could do is that this tangent has this triangle balancing on it. That's how I can describe it. So I know it's about the alternate segment theorem. So I know this 54 equals this angle here, or if I use angles in a straight line to find this angle equals this angle here. So I've got options. What I'm going to do is find this angle, so CDF. So CDF equals 180, take away 54, take away 66, because angles on a straight line equal 180 degrees. So that will give me, where's the calculator? I'm not doing anything in my head right now. $60. So I know this bit's 60. And I know that CDF equals CAD because of the alternate, sorry, CDF, this is the angle we just figured out here, equals the angle we're after here, because these are the opposite angles in the alternate segment theorem. Okay, so it is the alternate segment theorem. So CAD equals 60. I'm just going to label that there because they are the same. Because this triangle is balanced on the tangent, I know they're the same for the alternate segment theorem. Okay, so the answer is 60. Some of you achieved 60 but couldn't explain why. There's 3 separate ones that you need to be looking at there. Okay, and it starts with the 4-sided shape, the obvious one where they add up to 180 as an opposite angle. Okay. Okay, so composite functions. There's a couple of ways of doing this one. The easiest way, when you're given a number to substitute, is just substitute into the first one and then substitute that into the second one. You could, if you wish, substitute the function into the function first and then substitute the value, but I don't think that's wise. Okay, so the way to do it is to know which order you're going to do the substitution. So understanding how these work. So if I just write out so it's bigger, the 4 is going to be substituted into F, then substituted into G. So that's the way it's going to go. So we're going to substitute into F of X. So 3 times 4 squared. Okay. So 3 times 4 squared is 48. So that's the first substitution into F. So we've done this one, this is 48, and then we're going to substitute the answer into G. So there's G. So 1 over X minus 2. So we're going to replace the X with 48. So that becomes 1 over 46. Okay, nice and straightforward. Just haven't covered it in ages. Okay, so it's important for you to know that. The important part is knowing which order to go in. So starting from the right, they feed in that way, and it's very straightforward that way. Right, question 22. A plus root 8 squared, all squared, can be written in the form C plus D root 2, where A, C and D are integers. Find in terms of A an expression for C and an expression for D. Okay, so let's sort that double bracket out and see what we come up with. So A plus root 8 all squared is this. You will get credit for expanding this effectively, so let's just try and do that really clearly so we don't naff it up. So A squared plus A root 8 plus A root 8, that's an A. Root 8 times root 8 is 8. So that's what I've got so far. Okay, so let's consolidate, let's bring it all together. So A squared plus 2A root 8 plus 8. Okay, now that's what I've got so far. That looks nothing like what they said it might look like. It says it can be written like that. So the most obvious thing is that I've got root 8 and that's got root 2. So let's deal with root 8. Now root 8 can be simplified. Root 8 is actually 4 times 2. Because remember, when you simplify in a surd, you're looking for the square number. So I'm looking for 1, 4, 9, 16, 25, 36, 45. I'm looking for these numbers as a factor of that. And 4 is a factor of that. So I'm going to bring this down. I can square root that 4, and that becomes 2. So that's going to double the number on the front. So that's going to become 4a root 2. Okay, so at least I've got that bit. Next to root 2, I know I've got 4a. So D is actually 4a. So I know that bit. Okay. C is the thing that is added to this. Okay, so let's have a look what that means. Let's bring it down. Let's just collect it everything else on the left. So we've got a squared plus 8. They are adding to d root 2, or this root 2 thing. So all of this actually represents c, all of that. So it's going to be a squared plus 8. Okay, it's unusual that way. Typically, normally it means it might have just been like 8 like that, and it would just been one single value there. I have to admit, I did have a look at the mark scheme to see kind of what they'd deal with that bit there, or how they'd do it. Okay, because I was looking for a single term, but they're just showing you that if you actually read that or think about it, it's whatever is added to the root is c. Okay, so there we go. Right, these questions are not normally at question 23. They're normally like I don't know, in the middle somewhere, not at the end. Okay, and that's probably just because it's slightly harder, and we'll discuss why it is harder. Okay, I've only got a few questions after this. There's like literally 2. It's not many at all, really. So, the reason it's harder when we're solving, it will not say equal 3. So we're trying to solve by substitution. So what we're going to do, I'll show it's got solutions. We need to actually change this so it says equals 0. So we'll do that first. So we're going to take away the 3, or it's going to go to the left. Many of my kids or my students, you substituted, which you should do, okay, but you substituted when it said equals 3. Make it equal 0, then substitute. When I substitute 0 and I substitute 1, in the answer the sign will change. Okay, that's what we're looking for. That's how we'll demonstrate it. Okay, so that's what we're going to do. So we've rearranged it. Now I'm going to substitute 0. So I'm showing the substitution, although I'm just going to be typing it in the calculator. I'll show this substitution as well, where I'm substituting 1. I like showing substitutions like this because it's really tidy. You don't have to do any extra little bits and bobs. It can all be done at once. And it means that if I type it in the calculator like that, I only have to tweak the calculator later when I want to change the substitution. So that equals -3. So it's negative. If I try the other one, it should be positive. So you can see, look, so much quicker. Oh, that equals 3. So as the sign's changed, it shows us a solution. So signs have changed. There we go. Right, part B is just a fiddly substitution. It's not true rearrangement where you're just rearranging it. It's just showing that it can be rearranged. Okay, so you've got to try to make this happen. Okay, so you've just got to think, what have you got? What can you do? So I'm going to write this out again. I don't know why I do that. I just think I like it. I just think, how am I going to do this? And what you do is compare this to what you're trying to get. So if you look, you've got the 3 already on the right. It's over 4, but the 3 is still there. But the x cubed is on the other side, so that x cubed is going to have to go. So let's move the x cubed. So to do that, I'm going to take away 2x cubed. That's just to get it on the right there. So 4x equals 3, take away 2x cubed, which is nice because that's take away as well. So that matches what I'm looking for. And then, obviously I only want x, so that 4 is going to have to go. So let's get rid of the 4 by dividing everything by 4. That's the key bit there. So that divided by 4, hey up. And then this divided by 4. Okay. If you just quickly look at that, you've got 2 over 4. If I actually cancel those 2's out, the 2's out of that, you'll have 1x cubed over 2, which is the same as x cubed over 2. So that's how you show it. So you've really got to just look at what you're after and just think, well, what's moved? So just think what's still there, what's moved, and try and get to the solution that I'm looking for. Okay? Right then, starting with x equals 0, use the iteration formula of that 3 times to find an estimate for the solution of that. Okay, so they've rearranged this to make it an iterative function. We're going to start with 0, put 0 into this calculation, get that answer, put that back into the calculation again and again, and that's 3 times, and that'll be an estimate for the solution. Okay, so we're going to go x0, we're going to put 0 in, so let's have a look. So 3, there we go, you can see that there, look. Okay, that's me substituting the 0 in there. Okay, so my answer is 3. Well, there's a clever way to do this. If you put 0 in as your answer, then you can do 3/4 take away. Oh, that was cubed, by the way, wasn't it? Cubed. Don't forget that. Take away another fraction. It was the answer, so we can do alpha answer, but it was cubed. That's over 2. What that's going to do is substitute 0 in for me. It's going to do this bit for me. So you can see I've got 3/4, which is not difficult to understand because that's 0, so that just gives you that. Okay, so that's 3/4. Write it down. When I press equals now, what it's going to do, it's going to substitute the answer, 3/4 here, back into here. So I'm going to write down what that looks like anyway. So 3/4 take away 3/4 cubed over 2. That's what my calculator is going to do for me. You can put 0.75, and that gives me this time. So it's giving me 6/128. You can use decimals by all means. Okay, so that's once, twice. So we'll do it a 3rd time. You can see these are things I'm substituting in. Just being clear on the actual format there. You don't have to actually do that part. Okay. So 3/4 take away 69/128 all cubed over 2. That's what I'm doing, but again, I'm just going to press equals again. The calculator will automatically do that for me. So I've got 0.6716 blah blah blah. 77351. As an estimate, I'll say 0.67 is a reasonable estimate. Okay, it is a nice, easy one. Okay, and I am slightly surprised with how far back it is in the paper. Okay, that message is, if we carry on, if we hold out for these questions and look from at the back, don't think they're something more complicated than they are. And that was quite straightforward, and with a bit of practice, it doesn't matter what this looks like. If you know how to use the calculator and use the answer to substitute the answers in, it is really straightforward. Okay. In fact, I think I'll make that the theme of my intervention today, if you see me today. Okay, 24. The area of a triangle ABC is 42 centimetres squared. Find the length AB, so I need to find this. Give your answer correct to 3 significant figures. There is no right angle. Well, it doesn't say there is. It doesn't say anything about scale or anything like that, but don't go that way anyway. So I'm not using SOHCAHTOA. Can't use base times height divided by 2 because there's no height at right angle. Don't assume that's a right angle. Okay. So the only thing I do know about the area of a triangle when it's not a right angle is that I can use half AB sine C, the sine rule for the area of a triangle, where A and B are the 2 sides. Okay. And C is the angle that is trapped. Okay, so that's all I know really. So that's what I've got. So that's what I'm going to have to do. Okay, so let's start with that. We know that 42 is the area, so that equals half times by the 2 sides trapped at an angle. That's Miss Dallas trying to walk in sneakily. If this goes wrong, we know where to blame it. Okay, they're the 2 sides of the question. From the question, but the 70, the angle, is not trapped between 2 sides anyway, so the only thing I can figure out is this side here, so I'm going to call that y. I can find that one there. So I'm going to times that by 7, times that by y, times that by sine 70. Then I can unpick this one to use it to find some information later. Okay, so that's what I'm going to start with. That's the only starting block I've got. Okay, So we've got, what can we do? We can unpick it. So I'm going to first of all get rid of that half. So I'm going to times by 2. Actually, no, you think about it much clearer. These are all a big block of multiplication. When you've got a block of multiplication, you can take everything as a block, leaving what you want left behind. So I'm going to divide by half. I'm going to divide by 7. I'm going to divide by sine 70 all in one go, because that will leave me y by itself. That's what it will do. Okay, that's what will happen. So let's have a look what that looks like. 42 over half times by 7 times by sine 70. There you go. So the length of that side here, we think, is 12.77. Let's just look at kind of how many numbers I should use. It wants it correct to 3 significant figures, so this needs to be correct to 4 significant figures. So 0.77